What's up, you math nerds? Hope you're having a fabulous afternoon, evening, morning from wherever you're tuning in. My name's Miguel, also known as the Vegan Math Guy, and this is going to be Thursday's Math Survival Skills. Today, I want to cover AP Calculus exams. There is a huge exam coming up in May for the U.S. students that are taking the AP exam, but you're going to see that whether or not you are taking calculus or AP Calculus at all, you're going to recognize some of these questions, and I hope that you follow along. Just so you know, tomorrow I do have a free 1-hour webinar that you can sign up. The link is in my bio. And on Saturday, I am doing an AP Calculus full-length multiple choice exam and FRQs. That is awesome. That is good to hear you got a 5. I'm not sure how they do it in your school, but hopefully you're taking Calc BC now. Anyway, just so you guys know, I am trying to pull up the questions. Here we go. This is a multiple choice exam or multiple choice question exam. And just so you know, I do put the replays for this live on YouTube, and I will link this PDF for you to print out or just follow along as much as you like. So if you see something here, and if you feel like you already know the answer, go ahead and just type it in the chat. Jaden, that's great. So happy for you. Got your 5 and now Calc 2. Hope it's going well. Anyway, as I said, today is just going to be AP Calculus review. So if you're tuning in and if you want to continue prepping for the AP exam, or if you just want to follow some questions, feel free to do so. And again, always let me know what you think the answer is going to be in the comments. So for the very first one, it's actually interesting that we have this question here because we have the integral from 2 to x of this function 3t squared minus 1. And all they're asking us to do is to implement the first fundamental theorem of calculus. This might look a little different. People might think that they need to take the derivative of this because it looks kind of like the second fundamental theorem, but it's just going to be the first. So we're going to go ahead and take the integral of that function. That's going to be t cubed minus t, and that's going to be from 2 to 6. Oh, not 2 to 6. I'm sorry, 2 to x. And if you recall, again, first fundamental theorem of calculus is just plugging in that x into every value that we have there. And that's going to be x cubed minus x. And then we're going to subtract the value that we get when we plug in 2 into our new function. And that's going to be 8 minus 2. So if I simplify this, this is x cubed minus x minus 6. That should be our answer, and it looks like it was going to be option A. Really simple. You're going to see that the multiple choice question for the AP exam is that easy. As long as you continue practicing these questions, I mean, that multiple choice portion is going to be a breeze. Welcome everyone that's tuning in. We'll love to know where you're tuning in from, what calculus you're taking, or if you're going to take the AP calculus exam. Number 2, what is the slope of the line tangent to the graph y is equal to ln of 2x at the point x is equal to 4? Don't forget, immediately they say the slope of the line tangent to the graph. That's just another fancy way of saying the derivative. This is going to be AB. BC is very similar. It has different questions, but for the majority of this is going to be AB. I'll maybe do some BC next week, next Thursday. So as I said, the slope of the line tangent to the graph is just another fancy way of saying the derivative of the function at that point. So we're going to go ahead and take the derivative of y is equal to natural log of 2x. Who can let me know in the chat what the derivative of natural log is going to be? We have the 2x here. We're just going to go ahead and implement the chain rule. When we take the derivative of this, this is going to be 1 over 2x times the derivative of what was inside, so that's going to be 2. And if you notice, the 2's cancel out. This is going to be 1 over x. So that is a slope at any given point. All they're asking now is, well, what's the slope when x is equal to 4? So all we have to do is plug in 4 into this function, and that's going to be that the derivative, or the slope of the tangent line, is going to be 1 over 4. And that's our answer, guys. Option B is going to be your answer. Nice. I think Coop was already saying what the answer was going to be. Let's go ahead and erase this. Let's go on to the next one. And as I mentioned, I do record these and post the replays on YouTube, so you guys are more than welcome to go over those things. And on the YouTube video, I have the link to this particular test so you guys can just print it out or just follow along. Here we go. Number 3, they give you the function, and then they want you to find the derivative f prime at 2. Question. By the way, this is a AP exam. I forgot what year it is. So if you're understanding this, then you're going to have a great time, or you're going to have a really easy time when it comes to the AP exam. F prime of 2. First, we're going to go ahead and find F prime. And if you're very careful here, maybe I should, let me rewrite the function just because it looks like it's a little small. I'm seeing it on the screen that it's not really pulling up as nice as we want it to be. There we go. So it looks like this. F of x is equal to 4x minus 2, or 4x to the negative 2 power plus 1/4 x squared plus 4. Now we're going to go ahead and take the derivative. So all we're doing is implementing the power rule for this. We're going to bring the power down. This is going to be negative 8x to the negative 3 plus 1/2 x. If you're confused on that, be very careful. Make sure that you're practicing your fractions here and your negative exponents. Harry, what's going on? Oh, it's good to hear your trig test. You killed it. That's great. Good for you. Okay, so now we took the derivative. We're going to go ahead and just plug in 2 into that. So now we have, I'll just put it down here, f prime of 2. We want negative 8 times 2 to the negative 3rd power plus 1/2 times 2. For the first one, that's negative 8 times 1 over 2 cubed plus 1. Be very careful with that negative 3rd power, especially during the test. I know that, we can kind of get confused on that. But this is just negative 8 over 8 plus 1. So negative 1 plus 1, and that's going to equal to 0. Looks like someone had already said the answer to that. That's going to be 0. The derivative at 2 is going to be 0. That was option D. Easy enough. Okay, that was just question 3. Now we go to question 4. Integral from 1 to 2 of the function dx over 2x plus 1. Okay, so let me know in the chat, what should we do? I agree. Calc 3 is much easier than Calc 2. If you can do Calc 2, everything else is going to be a breeze. Calc 3 will be pretty easy for you, I would say. All right, guys, in the chat, what do we think? How should we approach this? Someone said, does it involve natural log? It absolutely does. Absolutely does. So we're going to go ahead and solve this using u sub. At this point, we should be pretty quick or pretty fast on solving these things, okay? U is going to equal to 2x plus 1. Just think of it. This is a multiple choice question. You should be able to do this like within a minute or 2 or less. Du is equal to 2 dx. We bring the 2 to the other side, so du is equal to dx. Oh, I'm sorry, du over 2 is equal to dx. And look what I'm going to do. I'm going to rewrite my integral. Instead of dx, I have du over 2 over our u value. And I'm going to change my parameters already. Let's just fix that. So when x is equal to 1, that's the one that we have there, we're going to plug it into this function. So that's going to be 2 times 1 plus 1. That's going to be 3. So that's going to be my new parameter there on the bottom. Now let's change it for 2. Let's go ahead and do the same thing. Plug it into our function of u. That's going to be 2 times 2 plus 1. That's 5. So now my parameter is 5. And before I simplify this, I have du over 2. I'm just going to put it on the outside. This is a 1/2. Integral from 3 to 5 of du over u. And this is a simple natural log. So now we have 1/2 natural log of u. And my parameters are from 3 to 5. You see why this was so much easier to change our parameters? Because now we don't have to plug in, we don't have to plug in the value of x back into the function. We're good. So now we have 1/2 natural log of 5 minus natural log of 3 by the first fundamental theorem of calculus. And what question was that? Or what answer? Looks like it was E. Be very careful here. If you look at the answers, they all look very similar, especially C and E. One of them had a 2 in the front. The other one had a 1/2. So we have to make sure that we're solving this correctly. Okay? So now let's go ahead and go to the next one. So many of you math nerds on here. Where is everyone tuning in from? I heard someone was from the UK. What else are we looking at? Jeff, there will be a series question if this was a Calc BC practice test. Right now, this is a Calc AB. But when it comes to those series, it's going to be very basic, like does it converge? Does it diverge? It's not going to be as complicated as you might think. Wow, Italy, buongiorno. Illinois, nice. Utah, wow, that's great. And we got Texas. Oh, Harry, I didn't know you were in Utah. That's cool. Alabama, let's go. Okay. No, I'm sorry. Albania, Philippines, Switzerland. Wow, that is incredible. From Florida. Oh my goodness. I'm out here in Washington and seeing all you lovely math nerds from all over the world. Georgia, Nigeria. Oh my goodness. That's Mexico. Wow. That's amazing, guys. I'm going to continue reading the chat, but I'm going to talk about number 5 here. So we have a piecewise function, and let's see what the question is. We want to know which of the following statements are true. This is typical. They love to give you something like this. So first, let's just go ahead and talk about the first one. They're saying that the limit as x approaches 2 from the left side is equal to f of 2. Well, let's look at that. Let's just kind of observe. You can kind of see my pencil here. This is great. So if I'm approaching the function from the left side and I'm going to 2, it looks like that limit, the one-sided limit, is -1, and that is in fact f of 2 because that's where it's defined. So we know that's going to be true. That's going to be a check mark. Now let's go to the next one. The limit as x approaches 6 from the left is the same as the limit as x approaches 6 from the right. Well, let's see. Let's look at this function. I'm approaching it from the left. Boom, looks like it's -1, and I'm approaching it from the right, and it looks like it's approaching -1. A lot of people get confused here because though there is a hole, we're just talking about the limit. We're just trying to see what is they're approaching, not necessarily what it's equal to, but what it's approaching. Okay, so now we know that the limit from the left and the limit from the right is going to be true. Aha, and then question 3, I didn't even read that. Look at option 3. Option 3 says the limit as x approaches 6 is equal to f of 6. Well, we know the limit from the left and from the right is -1. So that means that the limit is going to be -1. However, f of 6 is defined at -3. So those two things are completely different, and that's what they're testing you. Do you know the difference on f of 6 where the function is defined and what the limit is defined? So we know that option 1 is correct, option 2, that's true, but the third option is going to be false. So the only answer that we can choose is going to be option C. There we go. All right, let's go to the next one. Let me clear my drawings. Let's go ahead and go to number 6. Simple integral. I said integral. I'm sorry. Derivative. Oh, I'm getting so excited for this one because sine to the power of 3 or sine cubed of x squared. This is where a lot of people make mistakes, especially, I'm not kidding, when you're on a time crunch, you know your time, you have like these jitters, you're nervous. Slow it down. Be careful with this one. They're asking you to just take the derivative. And they love to give you this one because a lot of people forget about chain rule when it comes to this. So we want to take the derivative of this particular function. But let me just rewrite it a little bit. We have sine of x squared, and notice that I'm going to take the third power on the outside. I think that's the best way to visualize this. And now we're going to go ahead and take the derivative. We're going to implement the power rule, or I guess you can say chain rule here. We bring the 3 down, so this is sine of x squared to the power of 2. That was our new power. Times the derivative of what's inside. So now we got to take the derivative of that. And that's going to be cosine of x squared. Here we go. Times the derivative of what's inside again, because now we got to take the derivative of that, which is 2x. And some could argue that we got to take the derivative of what's inside of that one, which is x, which is just 1. But we don't have to worry about that. Okay, so this is our answer. Let's just kind of like simplify this a little bit. This will become, let me multiply the 2x and the 3. So that's going to be 6x sine squared of x squared cosine of x squared. That is our answer. Let's see which one matches what we got, and that looks like it was E. Oh, Matt, when you said E, I was reading the chat, and I thought you guys were talking about exponential E. Good job. I should be understanding what's going on here. This is great. Okay, let's go ahead and erase this. Again, there's a lot more people joining in. Don't forget, I do post the replays on YouTube, and I'll have the link to this so that you can continue to follow it. I am doing AP Calc Review every Thursday until the AP exam, and this Friday, I'm doing a free webinar that you guys can sign up on my bio. It's just integration techniques, and I'm doing a Saturday session where we're going to review a full-length AP exam. So we can go ahead and do that. This is all going to be via Zoom. So hopefully, if you guys want to check it out, go to the link in my profile, and you'll find it there. Number 7, we have a limit as x approaches infinity of x cubed over e to the 3x. All right, well, let's go ahead and use direct substitution. That's always the first thing we should try whenever we have a limit, and that's going to be that the limit, or first I'm just going to go ahead and plug it in. That's infinity cubed over e to the 3 times infinity. As you already know, that's just infinity over infinity. So what do we have to implement? L'Hopital's rule. Let's go ahead and do L'Hopital's rule. We started first and second derivative test today. That's awesome. Hope it's going well. I'm sure we're going to see a first derivative and second derivative test on here. L'Hopital's, the hospital rule is what they call it. So we're going to go ahead and take the derivative of the top, which is 3x squared, and the derivative of the bottom, which is 3e to the 3x. Again, we have to be really careful or like really efficient with our time and know how to take these derivatives very quickly, okay? If we implement or if we use direct substitution again, it's not going to work. So before I do that, though, I'm just going to cancel out the 3's and get x squared over e to the 3x. Again, if we were to plug in infinity, you will get infinity over infinity. Got to do it again. So we're going to go ahead and implement L'Hopital's rule. I guess I can put it here like L'Hopital's LH so people know what I'm doing. And this becomes 2x e to the 3x and then times 3 on the outside. Oh no, looks like we have another infinity over infinity. So we're going to implement L'Hopital's rule again. And now we have the limit as x approaches infinity of 2 over 9e to the 3x. Awesome. And now when we implement or substitute or direct plug in infinity into the x value, we're going to get 2 over 9 times infinity, which is just 2 over infinity. Now, what is 2 over infinity? Think about it. You have 2 pizzas and you're dividing it amongst infinitely many amount of people, or infinitely many people. So how much pizza does everyone get? Close to nothing, because you have to cut up that little pizza into infinitesimally small pieces, and so everyone's going to end up with no pizza. So in this case, the answer is going to be 0. Some people were saying bottom heavy. Yep, bottom heavy is a great way to describe it. This is AB. This is Calc AB. BC is very similar. You're just going to have series, and you're going to have all kinds of other stuff. Okay, I love this next question, number 8, because for some reason, some students don't learn how to substitute this, okay? So we have u equal to sine of 2x. That's exactly what they want. So they want you to rewrite the integral in terms of u. Okay, well, let me just rewrite the integral here. Integral from pi over 6 to pi over 2. We have sine to the 5th power of 2x, and we have cosine of 2x. And what they're saying is make u equal to sine of 2x. Okay, well, that's why they have all that space for us to do all the work. We're going to take our du. That's going to be cosine of 2x times 2 dx. Don't forget the chain rule. And we're going to bring the cosine 2x times 2 to the other side. So we have du over 2 cosine of 2x is equal to dx. Beautiful. And now we're going to go ahead and implement that into our integral. So we have the sine of u to the sine to the 5th power. That's going to become our u. So this is going to be u to the 5th power times cosine of 2x. We don't have anything written down for that, but then our dx becomes this blue portion here. So we have du over 2 cosine of 2x. So you're going to see, and I'm sure a lot of people already saw it very quickly, that the cosine of 2x cancels out. So now we could bring the 2 that's in a denominator, we're going to bring it on the outside. So 1/2 integral u to the 5th du. Now, it's definitely going to be one of these. If you look at this, it's B, C, and D, one of those, but we have to change our parameters. So how do we do that? Well, let's look at the pi over 6. We're going to change the pi over 6 now in terms of u. So you're going to plug it into this function here. U is equal to sine of 2x. So we're going to do u equals sine of 2 times pi over 6. If you simplify this, this is sine of pi over 3. And sine of pi over 3 is just going to be root 3 over 2. So that's going to be where I put my parameter. And then the other one, the last one is pi over 2. We're going to plug that in as well. Let me just erase I guess I could just do it down here. U is equal to sine of 2 times pi over 2, which means u is equal to sine of pi, and sine of pi is 0. So that parameter is just going to be up on top. So we have root 3 over 2 and 0. Looking at the options, it looks like it is option D. That's it. So will the bounds change? Yes. It looks like I'm reading that a little too late, but yes, they will change. Okay. Going on to the next one. Don't forget, guys, I post the replays on YouTube with the link to this particular test, and I'm doing AP Calc review every Thursday. Tomorrow I have a free webinar on integration, and on Saturday I have a webinar for an entire practice test that we can do. The link is in my bio. Please visit that if you are interested. Number 9, we have the function has the first derivative that's already given to us. At what values of x does f have a relative maximum? Oh no, here we go. This is dedicated to, I can't remember who's, to Travia, because they said they started first and second derivative. This is exactly what we're going to do. The derivative is here. Okay, we're going to go ahead and set that equal to 0. So the derivative is already given to us. So we have 0 equals x times x minus 3 squared times x plus 1. They make it easy because it's already factored out. So we know that the solutions to this derivative is 0, 3, and negative 1. Now, these are just the critical points. We don't know anything about them yet. So we have to go ahead and create kind of like I'm going to do a number line just to show, because we're trying to see where you have a maximum. So let me just kind of move this. Whoops, didn't want to do that. Too bad, I guess I did it. Let me erase this. There you go. So we're going to go ahead and create a number line. We have negative 1, we have 0, and 3. And we're going to go ahead and test points to the left and to the right of this. So we're going to test x is equal to negative 2, x is equal to negative 0.5, x is equal to 0.5, and then x is equal to 4. You're going to plug this into the derivative function, and all we care about is whether or not it's going to be positive or negative. So I'll just kind of put my work here on the bottom. When you plug this into negative 2, look at this. I'm not even going to solve it. I'm going to do negative 2 times negative 2 minus 3 squared times negative 2 plus 1. Notice how I'm not solving this. Negative 2, that's just a negative. Whatever you put in here is squared, so that's going to be a positive. That's not going to matter. So we have a negative times a positive. So far, our solution is negative. And then negative 2 plus 1 is a negative value. So we have a negative times a positive times a negative. That's going to be a positive value. So now we have a positive here. Okay? And so now let's go ahead and plug in a negative 0.5. So f prime of negative 0.5. So we have negative 0.5, negative 0.5 minus 3 squared, negative 0.5 plus 1. A negative, remember, that second part is always a positive, and then that's going to be a positive. So we have a negative. So on the inside, we repeat the same thing every single time. And what's going to happen is you're going to have a positive when you plug in 0.5, and then when you plug in 4, you're also going to have a positive. Okay? So what that's going to happen is all we care about is where we have a maximum. Remember, a maximum occurs where the function is increasing and then decreasing, and this is exactly what's going on. If we look at the number line, our function is increasing and then decreasing and then increasing again and then increasing onward. So the only time we have an actual maximum is going to be right there. So it is going to be at negative 1. Okay? So we have to be very careful with that. All right, cool. Let's go to the next one, number 10. So this is, you have two portions. This is without a calculator and with a calculator. Adam, yes, I totally could have ignored the piece. And that's kind of what I did. But if I do that, a lot of people are going to get confused and think, well, what happened to the squared part? But I 100% agree. Bro, I'm too slow because I'm teaching it for other people. That's the whole point. Otherwise, I mean, if it's just you and me, then we can just talk and I can talk about this quite fast. But there's going to be people that are confused. Trust me, I've seen it. Number 10, let f of x be the function from above and they want the value of b, so the function is continuous at 2. Love this because they give you a piecewise function. They're saying it has to be continuous at 2. First thing that we're going to do, if you notice the top, the x minus 2 can easily cancel out, or it's going to make the function undefined. However, we can factor out the top a little bit. This is going to become x minus 2, x minus 5 on top over b x minus 2. And then we have just the second function. The x minus 2's cancel out. And so now we have x minus 5 over b, and then we just have b for these functions. So they want this to be continuous, meaning that both of these functions have to be equal to each other when x is equal to 2. So all we're going to do is set them equal to each other, but we're going to make x equal to 2. So we're going to do 2 minus 5 over b equals b. Okay? So we're going to go ahead and take multiply the b to the other side, so we get negative 3 is equal to b squared. But then look at this, we run into an issue. If we take the square root to solve for b, we get the square root of negative 3. Just doesn't work. Just doesn't work. So there is no such value for this. So our answer is going to be E, but we have the right idea. We wouldn't be able to know what the answer to this was, but we have to always do it this way, okay? Whenever you have a piecewise function and talking about whether it's continuous, you just have to set that equal to each other, all right? Let's go on to the next one. Number 11. Okay, here we go. So we have a piecewise function from 0 to 6. This is the function of the derivative. They're specifically saying that this is f prime. And now what they want is they're telling you that the original function is equal to 1. What is the maximum value of f on the interval? This is interesting. What is the maximum value? Well, one of the things that you could do, gosh, there's so many ways of doing this. They give you that 0 to f of 0 is equal to 1. So one of the things that we can kind of like address here, they don't really tell you, but this looks like we have critical points at 0, at 3, and then at 5.5, okay? So we have to test for these points, okay? We have one of the maximum values. One way you could think about it is, since this is the derivative of the function, the original function has a positive derivative, meaning that it's increasing, and then you get to 3. So it looks like the function's increasing at some point. Give me 1 second. My tripod here is acting up. Okay, I think we're good. I have a tripod here, and one of the legs is like kind of slanted. Yeah. It's just a little insane. Anyway, going back to this, I'm sorry, guys. So as I mentioned, the function looks like it's increasing. It has a positive derivative, okay? And then it continues, and then it decreases at 3. So I guess let me just draw this a little better. It increases, and then it starts decreasing at 3, and then at 5, it increases again, okay? Now, you'll notice that the issue here is that 3 is the maximum, but that's not what they're asking. They want the absolute maximum value. So here's what you kind of got to do, all right? We're first going to go ahead and test, because it looks like the function increases, and it goes all the way to 3. So we're going to go ahead and test that. So we're going to do this. We're going to do the integral from 0 to 3 of this function. And if you recall, according to the first fundamental theorem of calculus, this is f of 3 minus f of 0. Okay, this is extra helpful because we know f of 0 is 1. That's great. We need to know f of 3. We don't know what that is. However, on this left side, the integral from 0 to 3 is the area underneath the curve of this function. And this is just a triangle. It's a triangle with a base of 3 and a height of 2. So this has the area of 1/2 base of 3, height of 2, is equal to f of 3 minus our f of 0, which is going to be 1. And so now this becomes 3 is equal to f of 3 minus 1. We could bring the 1 to the other side and get that 4 is equal to f of 3. Okay, that could be a maximum value. So far what we have is we have f of 0 is equal to 1, f of 3 is equal to 4. Well, we need to find the other values. Is there a possibility that maybe the maximum value is going to be at 6? Because at 5, we already know it's decreasing. So it looks like we just got to test 6. All right? So let's go ahead and do that. Let me just erase my work here. And the way we can do this is we can do the integral from 0 to 6 of the derivative, and that's equal to f of 6 minus f of 0 according to the first fundamental theorem of calculus. We already know this is 1. This is what we're trying to find, and this represents the area underneath the curves for all of these. So we already know this has an area of 3. So we have 3 for that area. We got to find the area of this other shape, which is another triangle. However, just be very careful because the base is 2.5. So this is 1/2 times 2.5 times, and then we have a negative height. So it says -2. And then we have the area of this little triangle up here, and that's 1/2. The base is 1/2, so I can do 0.5 times the height is 2. And that's equal to f of 6 minus f of 1, or f of 0, which we know is 1. So now we just got to kind of figure all these things out. That's 3. This one just becomes negative 2.5. So we have 3 minus 2.5. And then this one just becomes 0.5. And then we can bring the 1 to the other side and get plus 1 is equal to f of 6. Okay, so now what we have is we have 4 minus 2, minus 2, I'm sorry, is equal to f of 1, and this is 2 is equal to, whoop, I said f of 1, but it should be f of 6. Okay. Oh, geez. Even looking at this, it looks like we still didn't get the right value. So f of 6 is a lot smaller than f of 3, so even that's not an option. So it looks like we have to test all of these. Okay? So we have to test all of these. Now, I kind of want to continue with this with more questions. Or do you want me to test all the other points, or should we continue on to the next one? Let me know if you guys kind of got the idea of it, or if I should definitely just continue talking about 11. Yeah, it looks like... Yeah, there's got to be a quicker way. This one, you can... Well, I'm showing all the work, but for the most part, if you do it in your head, you're gonna have to test your values. The answer is gonna be D, by the way, but let me just show you why. Because if we do the area of f of 0, or 0 to 4, it's gonna be f of 4 minus f of 0, which we already know is 1, and this area we said was 3, plus just this little triangle here, which is gonna be just negative 1/2. And this becomes 2.5 is equal to f of 4 minus 1. Bring the 1 to the other side, and we get 3.5 is going to be our f of 4. So f of 4 is, wait, that's not going to be correct, because we said that was 3. It's not f of 4 then. But they're saying that it is. Did I do my math wrong on this one? Because it's not 1, it's not 1.5, not 2, so it's going to be one of the two options. I guess that's the one way we should have done. But anyway, so it looks like out of these two, so f of 4, if we do that, it's going to be 3.5. So f of 4 was 3.5, and f of 6, I believe we got 2. So looking at these options, f of 3 wasn't even part of the multiple choice, so I should have actually done some better work on here. So the answer is going to be between 4 and 6, and 4 looks like it has the largest value. One way we could have done it, okay, is looking at all these options, 1, 1.5, and 2, that's the area from 0 to 1, then 0 to 1.5, and 0 to 2. The area is still larger here at 3. So we could have honestly said, well, 3 is still larger than that, so it can't be any one of these. And then we had to just test 4 and 6. This is one of those times where could have definitely thought about it, and you are going to definitely approach questions like this on the exam, and it's like, okay, well, I took too long on this one. All the other ones should not take that much longer. And the answer is D, by the way. I know a lot of people are arguing or like trying to argue that it's aware iPhone. It can't be D because the function is negative then positive, meaning that it's a minimum. The answer is just saying f of 4. Because this means that the function is increasing, going all the way to 3, and then starting to decrease, going to 4. Yeah, the answer is telling me that it's D. Literally, in the answer key, it is saying that it's D, which is interesting. But anyway, let's talk about it. Let's go ahead and go to another question. But I do agree that this is a little confusing, but it looks like the answer was D. And when we did it, f of 4 was larger than f of 3. So let's go to number 12. Let me go ahead and erase that. Okay, so we have a function. If 4 subintervals of equal length are used, what is the value using the right Riemann sum from 0 to 2? Okay, so we're trying to find the integral from 0 to 2 of this function. And the way we're going to do it is we have this function that kind of looks like this. We have the area underneath the curve from 0 to 2, but they want 4 equal subintervals. So we're going to cut these up into halves. So we're going to have different triangles, and it is going to be a right Riemann sum. So the triangles are going to look like, or the rectangles in this case, I'm sorry, are going to look like this. And the way we can do this is every single rectangle here has a width of 1/2. So we're going to do 1/2 times, and then now we're just going to take the right values of each function here. So for the first rectangle, we're going to take the y value of 0.5. So we're trying to do f of 0.5 plus f of 1, that's the next value. And then we go to the next rectangle, that's f of 1.5 plus f of 2. And this just becomes 1/2 times, and now we have 9 to the power of 1/2 plus 9 to the power of 1 plus 9 to the power of 3/2 plus 9 to the power of 2. Let me erase that. Okay. 9 to the power of 1/2, that's just the square root of 9, so that's going to be 3. So we have 3 plus 9 to the power of 1 is 9. This one is a little confusing. 9 to the power of 3/2. So first you have to take the square root of 9, which is 3, and then cube it. So that's going to be plus 27 plus 9 squared, which is going to be 81. Now we have to add all these up. That's going to be 12 plus, let's see, that's going to be 8, 108. And if we add that, that's 1/2 times 120. I'm already thinking of what the answer is going to be. And that's going to be 60. So that's going to be C. Okay, I'm trying to read the comments. Do you guys want to go back to that particular problem? Again, the answer said it was D, but I don't know if we want to continue talking about that one. We'll go back to it if the chat wants to continue reviewing that question, okay? So let's go to 13. Yes, it will be on our YouTube channel. Watch it back. And again, if you guys catch any mistakes on that, especially number 11, keep your eye out on that. Because again, I'm trying to solve all these problems correctly. I'm looking at the chat at the same time. So maybe I made a mistake. But again, I will post this on YouTube by the end of the day. So if you guys want to continue to discuss it, let's do that. Or we can join the Discord and we can continue talking about it then as well. All right, so let's go to number 13. They just want us to take the derivative of this. What do we have to do? Quotient rule. First, let me just go ahead and write this. I'm going to write it out as bigger, in a bigger writing. Yep, I think that's a lot better. So now what we're going to go ahead and do is implement the quotient rule. That's x squared plus 1, low, times the derivative of x plus 1, which is 1, minus x plus 1 times the derivative of the bottom value over the bottom squared. And so now we have x squared plus 1 minus, we have to be very careful here. I'm going to distribute the 2x to both of these terms and distribute the negative sign at the same time. So that's going to be minus 2x squared minus 2x all over x squared plus 1 squared. And let's just simplify these things. We have an x squared and a minus 2x squared. That's a negative x squared minus 2x plus 1. Looks like nothing else is going to cancel out. And it looks like the answer is going to be C. Low D high minus high D low over low low. Always, that's the same. Wisdom, what is the channel called? You just go to my profile here on TikTok and it has a YouTube icon. But if you want to look it up, it's the same as my username here, the Vegan Math Guy. All right, let's go on to number 14. Here we go. So number 14 is telling us that the velocity of a particle is moving along the x-axis and it's given by that velocity. If the particle at x is equal to 4, or if the particle is x is equal to 4 when t is equal to 0, what is the position of the particle when t is equal to pi over 2? This is a classic question. This is a classic question that you're going to get where they give you the velocity and they want to give you, or they want you to find the position at some point. You can do this in two different ways. You can find the position function by taking the integral and doing the plus c stuff and then plugging in the pi over 2. Or you can do this. You can take the integral from 0 to pi over 2 of the velocity function, because don't forget, according to the first fundamental theorem of calculus, this is the position function at pi over 2 minus the position function at 0. Now let's just rewrite a few things. This is still the integral. Now I'm going to write the actual function they gave us. This is sine of 2t dt. We don't know what the position is, but we do know that s of 0 is 4, because that's what they told us in the beginning. And now we're just going to go ahead and solve for this. This is going to be cosine of 2t, or negative cosine of 2t, I'm sorry, over 2 from 0 to pi over 2. Someone was just talking about how I'm taking too much time when I solve these. This is something that you should be able to do pretty quickly during the exam. So all I did was I kind of use substitution, integrate it, and then put the 2 on the bottom there. And now I can go ahead and plug in pi over 2. So I have negative cosine of 2 times pi over 2 over 2 minus negative cosine of 2 times 0 over 2. And that's equal to the position at pi over 2 minus 4. That first one, 2 times pi over 2, that's just pi. Cosine of pi is negative 1, so we have positive 1/2 minus, we have 2 minuses there, so I'm just going to put a plus. Cosine of 2 times 0, that's 0. Cosine of 0 is 1, so this is 1/2 is equal to s of pi over 2 minus 4. This, you add that up, that's going to be 1. So we have 1 is equal to this whole thing. Let's bring the 4 to the other side. So we get 5 is equal to the position at pi over 2. And that is going to be our answer, D. Harry, yes, I got a degree in math. Just pure math. I think the goal was to, actually, I don't know what I wanted to do. Some people said that I was only going to end up teaching, which I kind of am doing now. But I've been doing I have a private tutoring business, and now with the rise of TikTok and Instagram and YouTube, I now make part of my living not only doing private sessions, but also doing this stuff for you guys. So if you like what I do, please support it anyway. You can subscribe here. So follow me on TikTok. Subscribe to my TikTok. Follow me on Instagram or YouTube. So any support, the more you follow, the better. Here we go for number 15. They're telling us that g of x is a differentiable and increasing for all real numbers. So what does that mean when it's increasing for all real numbers? That means that g prime of x is greater than 0 for all real numbers. What interval of the function is this increasing? Okay, well, they give us the function g of x cubed minus 6x squared, and they're trying to ask when it's increasing. In other words, when is the derivative of that going to be increasing? Or when is that derivative of that going to be greater than 0 or positive? Well, we're going to take the derivative. took my derivative there, but I have to apply the chain rule, which is 3x squared minus 6x. Okay? Now, they're telling us that no matter what we plug in here, this is always going to be greater than 0. This is always going to be positive. So we could almost just ignore that. That's how they want to confuse you, because this is always going to be positive. We really care about when this becomes positive or negative. So if we try to find the values of this, or the critical points of this parentheses here, we can go ahead and factor out a 3x and get x minus 2 in the parentheses. So now we have two critical points. We have 0 and 2. And we can go ahead and plot those into the number line. So we can test -1, we can test 1, and we can test 3. If you plug in -1 into this, again, we don't care about this because that's always positive. When you plug in -1 here, you get 3 times -1, so that's a negative, times -1 times negative, or -1 minus -2. I'm sorry, -1 minus 2. That's also a negative. So we have a negative times a negative, that makes it a positive. You could do the same thing for 1. 3 times 1, positive. 1 minus 2, that's a negative. So those multiply together, make it a negative. And we'll do the same thing for 3. A positive, and then that's a positive, so that's a positive. So when is the function increasing? It's between 0 and 2. Oh, negative 12x. Oh my God, I was looking at this. I'm sorry, guys. Thank you. Thank you. Yes, negative 12x. No wonder nothing was showing up there. No wonder. Oh my gosh. So that's so embarrassing. But yes, everyone's in the chat. Thank you so much. It's negative 12x. When I took the derivative of that, that's what happens to me. I should have been reading the chat there. When I took the derivative, this was a negative 6x. Big boo-boo. That's negative 12x. And then when I factor out a 3x, that should have been x minus 4. So then our point out here should have been 4. So when I test, instead of I should test 5 for this one. So it's going to be the same thing. 3 times 5 is positive. 5 minus 4, I'm sorry, is positive. So a positive value, and that's a plus. So when is it increasing? We found it from negative infinity to 0. Union from 4 to infinity. Okay. Now, here's the thing. I typically put parentheses. A lot of people like to put the brackets, and that's how they have it on here. I'm very, worried about that. If it's a multiple choice, I mean, you could put including, but technically at 0 and 4, it's not increasing, though. The whole derivative is 0. So I'm curious about that. Anyway, thank you so much to the chat. Ethan and Visibilize. Maybe I'm pronouncing that wrong, but yes, made a huge mistake there. I am so sorry. Okay, so now let's go to number 16. I'm just going to leave the writing up here on there. Number 16, they want us to find the limit as x approaches 3 from the left side. Let me just write that a little bigger. So this is limit as x approaches 3 from the left side of absolute value of x minus 3 over x minus 3. Okay. So what they want is we have to plug in something to the left of 3, something that's really, really, really close. So how about, just think about it. If you have a number line here, something to the left of 3 is like 2.99999. So let's plug that in. 2.999 minus 3 over 2.999 minus 3. Now here's the thing. This becomes something really, really small, negative 0.001, but you have the absolute value. So it's still just a positive 0.001. And in the bottom, you're going to get the same thing. So you really have the same function, or the same value, over 0.001, something really, really small, over that same value. On the top, it was positive. So now we know that this is just going to equal to 1. That's just the limit as x approaches 3 from the left side. Harry, why wasn't that last question, number 15, product rule? Because it was a chain rule. It was g of this function. So I did g prime of the stuff that's inside times the derivative of that value. So this is where I have that g prime. G prime of x cubed minus 6x squared times the derivative of that. All right, let's go to the next one. I still have plenty of time that we can continue to review these things. Here we go, f of 17. So or f of 17. Jesus. Guys, I'm like reading so many things all at once. F of x is equal to a times e to the negative a of x for a function a, or for a value a that's greater than 0. So we just need to find the derivative. All they're saying is that a is a constant. Let's not worry about that. So f prime of this function, well, first let's just go ahead and write the function. F of x, someone was asking if it was -1. The absolute value made it 1. I'll go back to that problem. But again, answer key. Holy fuck, guys. 3, 2 minus... Oh, it was -1. You're absolutely right. I'm just not... Okay. Guys, this is like the biggest L. I'm going to go back to 16 real quick because someone was saying that the bottom was negative. You're absolutely right. This is just me jumping into conclusions. I'm not going to make this mistake again. So the idea, again, people are bringing to my attention, you bring in x minus, or you plug in something to the left of 3. So it's just 2.9. So you have 2.9. I'm just going to do 2.9. I don't want to write the 2.99. 2.9 minus 3. On the top, I said that was negative, but then because it's the absolute value, it turns it positive. But on the bottom, 2.9 minus 3 is a negative. So the answer should be -1, not +1. So you're absolutely right. Thank you, guys. Thank you. Okay, so let's move on to this one real quick. This is our original function, a e to the negative ax. And now we're going to go ahead and take the derivative. So remember, a is just a constant. It does not matter. So a is going to be on the outside because it's just a constant times the function. And that's going to be e to the negative ax, it's the original value, times negative a. That's just a derivative of the power there. So this becomes negative a squared e to the negative ax. That is our derivative. That's all they want. That's all they want. So the answer is going to be e. All right, let's go on to the next one, number 18. Here we go. Oh my goodness. Can you guys read that? Because it looks like you guys need to be able to read step 1 and step 2 and step 3, because it looks like you need to be able to kind of... Can you guys read that okay? So here we go. They are given a function, dy over dx is equal to xy, and they give you the condition. So they want to say which steps are incorrect. Okay, so where does the error occur? So if we were to do this, the very first thing that we want to do in the very beginning is multiply the dx to the other side and divide by y, because you want to be left with dy over y is equal to x dx. And then we're going to be able to take the integral. That's step 1. That looks good. So now we go to step 2, where we have to integrate both sides. The integral of 1 over y was natural log of y. And the integral of x is x squared over 2 plus c. Looks like that's still correct. And then we get here, and they wrote this as y is equal to e to the x squared over 2 plus c. So how did they do that? It looks like they took e to both sides. But that's where the mistake is going to be, because that should not be a plus c. It should be a c times that. So step 3, why? Because e to the x squared over 2 plus c, notice that the c is still a power, is the same thing as e to the x squared over 2 times e to the c. Because when you have the same base, then you can go ahead and add the powers. Now e to the c is just a constant, so that becomes e x squared over 2 times c. That's where they made their mistake. It should not have been a plus c. And that was going to be step 3. Oh, someone said they didn't exponentiate the constant. That's a great way to describe it. That's exactly what happened there, guys. So can I explain what an arbitrary constant is? It's just going to be, it could be 1, it could be 2, it can be 3. For the most part, for this exam, you don't have to think about it too much. Whenever they say it's an arbitrary constant, it's just 1, 2, 3, 4. It could be an integer, really. And C could be written as A. You're absolutely right. This is just in this class, they use calculus or they use the constant. They write it as C. But you're right. It could be A. Doesn't matter what it is. You can put happy face for all you want. Doesn't matter. Okay. Let's go on to the next one. Let me go ahead and erase my work. Whoops. Let's go to 19. Ooh, for what values of x does this function have a point of inflection? How do we find point of inflection, chat? Who can give me some pointers on here? How do we find the point of inflection? Need to find the second derivative. Yes, Brian, yes. You need to find the second derivative. No skills. During the AP exam, maybe don't do it, but during a calc exam with your teacher in high school, put a happy face. Why not? But putting a plus, putting the happy face during the AP exam, the proctor might be like, nah, I'm not dealing with that. So just continue making sure you put plus C. But C, you can put whatever. You can put a happy face. You technically can. Yes, so we have to check when the second derivative is 0 undefined. And not only that, you're going to see. We're going to take the second derivative. So 15x to the fourth plus 40x cubed. Make sure I'm taking my derivative right because clearly I can't multiply stuff. Now my second derivative, that's going to be 60x to the third plus 120x squared. Hoping that looks good. I'll read the chat to see if I made any mistakes there. Then we're going to set this equal to 0 because that's what we're trying to find. And I'm going to go ahead and factor out a 60x squared. Looks like that's something they have in common. 60x squared times x plus 2. Ethan, we could probably do power series tomorrow. So tomorrow's going to be off-trail math. Today is just going to be AP Calc. But maybe tomorrow, yeah, we can do a lot of stuff on that. So looking at this, we have 60x squared times x plus 2. So we have two values where the function is equal to 0. That's 0 and negative 2. Now, we can jump into conclusions and say that that's our answer. Okay? 0 and negative 2. But that's going to be incorrect. All right? Because, yes, so visibility is saying over here that it's not only about the second derivative being 0 undefined, we also have to check that it actually changes sign. So it's a little different than what we're used to seeing. Okay, it's not like the critical point. We have to just make sure that the values change. So we have negative 2 and we have 0, and we're just going to test some points. So x is equal to negative 3. X is equal to negative 1, x is equal to 1. And you plug that into the second derivative. So let's do this real quick. Now that we kind of talked about changing the sign, okay? Make a sign chart or you can do a line test. It doesn't matter what you want to do. So negative 3. I'm not even worried about this value here because whatever you plug in, it's always positive. So again, not worried about it. What I'm worried about is the inside. So when you plug in negative 3 plus 2, that's negative. When you plug in negative 1 plus 2, that is positive. And when you plug in 1, you get 1 plus 2, that's 3, that's positive. Look at that. So it goes from negative to positive and then positive. So the only real point of inflection here is negative 2. Okay? Yeah, people make sign charts. You can absolutely do that. I like doing the number line. I used to do a sign chart when I was in high school, and then I just somehow got lazy and started doing the number line. So you can do whatever you want. Okay, so now we know it's going to be negative 2, so the answer is going to be B. So you got to be careful. Immediately when they give you that point of inflection, they love to fuck with you with that because they know that a lot of people are going to take the second derivative, set it equal to 0, find the value, and say, oh, we're done. No. Because look at that. We had 3 different options. We have B, C, or E. So you got to test the points of inflections. Okay? Don't let them fool you. All right, here we go, guys. Number 20. Number 20. We have the limit of this function minus ln of 5 over x minus 2. Interesting. Very interesting. I can definitely... why does this look a little weird? Oh, I keep thinking that it's the definition of a derivative, but it's not. One thing that you always should test is direct substitution. I know it's not going to work at this point. Was someone already putting the answer to this one? If so, that's the case. That's impressive, bro. But let's talk about this real quick. Let's talk about why the answer. Someone already put it in the chat. When you use direct substitution, you get ln of 5 minus ln of 5 over 0. So 0 over 0, so we can use L'Hopital's. Take the derivative of the top, that's 1 over x plus 3, minus 0 because the derivative of ln of 5 is 0 over 1. The derivative of x minus 2 is just 1. So now we have the limit as x approaches 2 of 1 over x plus 3. And now all we have to do is just plug in 2 into there, and we get 1/5. Don't forget your L'Hopital's rule. AP, the calc, is not a time for you to kind of, be a hero and try to simplify things. Use L'Hopital's rule, okay? It's there for a reason. W L'Hopital. Let's go to the hospital, baby. All right, guys, I think I have time for maybe one more question. Unfortunately, let's do... Okay, we'll just do the next one. And don't forget, I do have the replays. I'll post on YouTube. Fridays or tomorrow, I'm doing an integration 1-hour webinar on just different integration techniques. Saturday, I am doing a full FRQ and multiple choice exam. If you guys want to join, the link is in my bio. All right, so let's go to 21. Was it 21? Yes, it is. Okay, so we have a function x, y, w, x, and y, and they're differentiable with respect to time and related to this function. If x is decreasing at a constant rate of 1 unit per minute, and y is increasing at a constant rate of 4 units per minute, at what rate is w changing with respect to time when x is equal to 6, y is equal to 20? Yo. If I'm joining on Zoom, why does it say join audio? Am I recording on Zoom here? Oh, I see. This, you're absolutely right. So, no skills. I am on Zoom right now on this computer, but I am sharing this. I am going live on my phone. That's why. So, I'm going on Zoom here because I need to type all the stuff using my iPad, which is this right here. So, that's where I'm writing stuff. So, I need to kind of be on Zoom at the same time. Someone said implicit. This is technically implicit, but this is going to be a related rates problem. AKA, it's an implicit problem. So W is equal to x squared y. That's the equation. Then they say that x is decreasing at a rate of 1 unit per minute. X is decreasing at a rate. They're talking about a rate. So that means that dx dt is equal to -1 because it's decreasing. And then y, so dy dt, is increasing at a rate of 4 units per minute. That's what they tell you. So we need to find dy dt when x is equal to 6, y is equal to 20. Okay, so we're going to go ahead and actually show our work right underneath. So let me just kind of block that here. Okay, so we're going to go ahead and take the derivative of this. So we start off with this function. We're going to take the derivative of both sides in terms of t. So on the left side, the derivative of w is 1, but then times dw dt. This is the implicit differentiation part. And now on the right side, we're going to take the derivative. We're going to use product rule. So the first derivative is going to be 2x dx dt, because remember, we're taking the derivative in terms of time, times y, plus x squared times 1 dy dt. Let me kind of simplify this without the ones there. So we have dy dt equals 2xy dx dt. I just kind of rearranged this first term. And then this one over here plus x squared dy dt. And now we're supposed to find dy dt given x, y, dx, and dy. So we're going to do 2 times 6, because that's the x value, times 20 times -1. Again, 6 was the x value, 20 was the y value, and then dx dt was our -1, plus 6 squared times dy dt, which is 4. And now we're just going to simplify. So we have negative 240 plus 36 times 4. So negative 240 times 154. I hope that's correct. And this is going to be negative 96. No, wait, am I correct there? Negative 240. Is this negative 96? It is negative 96. Yep. So it's going to be C. 21 is going to be C. You got to be very careful. Someone said B, negative 240. Don't forget we had to multiply or add that to the 154. Okay, this is a non-calculator portion, but as you can see, sometimes you can make very, very costly mistakes. Okay, I already did. I'm going to say I made one big mistake. The other one, I kind of screwed up on it. But again, I post the replays on YouTube, so if you guys want to discuss that, please make any comment about it, because that will be great. Okay. All right, guys, that does it for today. It was a really long one. I'm really happy about that. But keep in mind that I am out here every Tuesday for Integration B. I am out here for going back to this problem, 240 minus 154. No, it wasn't 144. Okay, anyway, again, if you guys see that mistake, again, I looked at the answer key, did that correct. However, again, this does it for today. I am here every Tuesday for Integration B. On Friday, or Thursdays, I am here for Math Survival Skills like we did today. And on Friday, we're going to do some off-row math. So join me around the same time. I am always here. And if you like, follow me on TikTok, follow me on Instagram, follow me on YouTube, and we'll continue talking math then. I hope you guys have an amazing Thursday, an amazing end of the week, and I'll see you guys real soon. All right, everyone, have a good one.